Probability puzzles feel hard because the math is usually easy, but the information overlaps. Venn diagrams exist to handle that overlap cleanly. They work because they break a messy situation into non-overlapping pieces. And once nothing overlaps, probability becomes simple bookkeeping. Start with the picture. The rectangle is the sample space, meaning everything that could happen. All probabilities inside that box must add up to 1, or to the total number of people in a survey. Each circle is an event, like liking maths or liking science. Being outside a circle matters just as much as being inside because it represents the complement, the outcomes where that event does not happen. With 2 events, the diagram automatically splits the situation into 4 disjoint regions. In both events, in A only, in B only, and in neither. These 4 regions do not overlap and they cover everything. That's the key. Any probability question is really asking which of those regions to add together. This is where wording becomes precise. A and B means only the overlapping region. A or B means every region inside either circle, including the overlap. A but not B means the A only region. Neither A nor B means the region outside both circles. Most mistakes come from mistranslating these phrases, not from calculation. The diagram also explains why we subtract intersections. When you add P of A and P of B, the overlap gets counted twice because it belongs to both circles. Subtracting the intersection isn't a trick. It's correcting double counting. The formula P of A or B equals P of A plus P of B minus P of A and B is just a sentence describing the picture. In survey problems, it's usually best to work with counts first. If 60 people like maths, 50 like science, and 30 like both, you place 30 in the overlap first. Then maths only is 60 minus 30, science only is 50 minus 30, and whatever is left out of the total is neither. The order matters because totals already include overlaps. Filling the center first prevents subtraction errors. Conditional probability becomes clearer visually as well. P of A given B means we are told B has happened, so everything outside the B circle is irrelevant. The B circle becomes the new sample space. The probability is the overlap divided by the whole B circle. The diagram makes the correct denominator obvious. With 3 events, the idea does not change. 3 circles create 8 disjoint regions. You work from the deepest overlap outward. First the triple intersection, then the regions with exactly 2 events, then the single-only regions, and finally neither. It looks more complex, but it's the same bookkeeping principle. Venn diagrams are essentially a visual version of inclusion-exclusion. They ensure that every atomic region is counted exactly once, no more, no less. That's why they prevent common errors like double counting, forgetting overlaps, confusing and with or using the wrong denominator in conditional probability. They do have limits. Beyond 2 or 3 events, diagrams become cluttered, and other tools like tree diagrams or tables work better. But for standard probability puzzles, Venn diagrams don't magically solve the problem. They organize the information so the solution becomes unavoidable.